I hope you did well on the quiz. Trust there were no problems. Excited to hear that. We're going to talk about a couple of different things, a couple of important things about word problems here. All of them involve using the calculator. Okay, that's the important part. So I hope you have your TI 84 ready, 83, 83 plus, 83 platinum, 84, 84 plus, 84 silver. You get the idea. Okay, so the first kind of problem we're going to talk about is called projectile motion. Okay, this is something that's going to be shot from the ground up into the air, or it's going to be from the top of a mountain or building top. We're going to throw something up in the air, and then we're going to see how long it takes to hit the ground. And this is an equation for this. Now, you don't have to memorize this equation that you see here, and it looks very difficult, but it really isn't, I promise. And we're going to go through each of these terms as we hit them. But it's 1/2 g, which is for gravity. And we'll note specifically that it's time squared. So t is our variable. Velocity, initial velocity is v sub 0 times t plus h sub 0. Okay, the subscript sub 0 means initial condition. So that's when time is equal to 0. So t is going to be time, usually in seconds. And the initial velocity will be represented by v sub 0. So if I drop something, the initial velocity is 0. If I throw something in the air, then I have a velocity going upwards or downwards, depending on how I throw it. The initial height is what we started. So we start from the ground, it'll be 0. If we start from a building, it'll be whatever, however tall the building is. The leading coefficient comes from the force of gravity. So this is always a given. It's either negative 9.8 millimeters, not milli anything, meters per second, or negative 32 feet per second squared. And that just depends on whether we're doing feet or meters, and it's times 1/2. So basically all of our equations are going to have that part of it. Okay. So let's look at example 1. And by the gravity is a constant. You should probably already know that. An orange is launched at 19.6 meters per second. So that's our initial velocity. That's our v sub 0. From a building that's 58.8 meters tall. Okay, that's our starting height. That's our h sub 0. The equation for that object's height, s. So s is height, and t is time in seconds after launch. S of t, that's our y in this equation. Negative 4.9, because we're doing meters, so we take half of negative 9.8, negative 4.9, plus the initial velocity, 19.6 meters per second, times t, plus the initial height, 58.8 meters, where s is in meters. Okay, so the question says, when does the object strike the ground? And what I want us to do now is put this equation into our calculator. Okay, so let's go to our calculator and put the equation in. So now that we have here at the calculator, I've gone to y equals. Okay, I've gone to y equals, and here I am. Now, if you have this stat plot on, make sure you turn that off, because that's going to cause you trouble. Shouldn't have it on. I think we turned it off last class. Go down to this y1, hit clear, and then clear anything else that's there. Okay. I'm going to go back to second table set, and I'm going to take it off of auto, or off of ask, and go back to auto. Okay, so I just want to be there. I'm going to start at 1, but we can change that as we need to. Okay, so go back to y equals and put that equation in. So that was negative 4.9. Now we don't have a t, so we're going to use x and then squared. Okay, make sure you use the negative, not the subtraction sign. Plus 19.6 t, which in this case is x, because that's what we have, plus 58.5. Okay, that's the equation. I'm going to hit graph. And I don't see it all, right? Remember, this is my standard negative 10 to 10 window. So if you think about the window, we need to change the window. Okay, so if I go to window, I don't need to change the x max or the x min, right? Left and right is fine. I need to change the height. I don't need to go past the x min, because the question's asking, or excuse me, the y min. The question's asking us, when does it hit the ground? Well, the y coordinates are the ground, so that happens when y is equal to 0. So I don't need to go to that. But my x max, I'm going to need to increase. Remember, our starting height was 58.8 and it was shot upwards. So I don't know. I'm going to put in 100. I don't really know what it is, but I feel like that's going to give me a good view. And let's hit graph. And there we go. Okay. And what I like about this is sort of like what would happen if you shot something off a building, right? Here it is. It goes up into the air and then it falls to the ground. Okay. Everything that's happening to the left of the x or the y axis doesn't matter because that's at negative time and that doesn't exist in the real world. Okay. So the question is, when does it hit the ground? And you can see it hits the ground when it hits the x-axis, right? In this case, the x-axis is the ground. And if you remember how we find that coordinate, we can go to second trace, which is calculate, and then number 2, which is 0. We do our left bound and right bound. So I can just hit enter here. And then I'm going to take it all the way to the right. So I'm hitting that cursor. I can hit enter. It's going to find the 0 between here. I hit enter, and that occurs at 6. So when t is 6, it hits the ground. T equals 6 hits the ground. Okay, so if you go back, you could have done all this on the calculator, and you can say t equals 6 is when it hits the ground. T equals 6. Now, the other way you can solve this, if you choose, is to use the quadratic formula. Like, we want to know when the height is 0, so we're going to replace s of t with 0 equals negative 4.9 t squared plus 19.6 t plus 58.8. Okay, and you could do negative b plus or minus the square. Are you already horrified by how long this is going to take? 19.6 squared minus 4, negative 4.9, 58.8, all over 2 times that. Now, look, you want to do this? Feel free. Do the quadratic formula. You should get t equals 6. Okay. I'm just telling you the calculator makes it so much nicer. The calculator makes it so much nicer. Okay. T equals 6 is our answer here. And you can see right there, it's so much easier. Okay. So that's one. That's how you do one. You put it in the calculator and you say, what is it looking for? Is it looking for the 0? Is it looking for an intersection? Is it looking for the vertex? And that's really what we're going to try to figure out on these problems. Okay. Let's skip to number 3 and then we'll come back and do number 2. Okay. We'll come back and do 2. But I think it'd be better if we did 3 first because it's a very similar kind of problem as number 1. So Marcia hits a tennis ball upward on the top of a 90-foot high cliff with an upward velocity of 16. So that's our V sub 0 right there is 16 feet per second. So feet per second tells me I'm using the gravity equation for feet. Marcia hit the ball when it was 6 feet above the top of the cliff. Okay. So assume the tennis ball will hit the ground below the cliff. Determine the equation for the height of the ball after t seconds. So that's just saying come up with an equation for this. So we're going to say s of t is equal to, now remember it's 1/2 of feet per second, so 1/2 of 32, so it's negative 16 t squared, negative 16 t squared, plus the initial velocity, plus 16 t, plus the starting height. Well, the starting height is the cliff, 90 feet, plus when Marcia hits the ball, throws the ball up. She hits it when it's over her head. It's 6 feet above the top of the cliff. So 96 feet. So that's my equation. And remember that negative 16 comes from the fact that the gravity here is in feet per second. It's at negative 32. Okay. Now graph the function and then find the number of seconds it will take the ball to hit the ground. Okay, how long will it take the ball to hit the ground? Again, you could use the quadratic formula to solve this, but we're letting you use a calculator, so use the calculator. Okay, so I'm just going to clear this old graph out, go to back to y equals, clear it out, and then I'm going to do negative 16t, which is now x because I don't have a t here, plus 16t plus 96. Now I can hit graph again and see what it looks like. I might change my ceiling just a shade, because look, I kind of see that. I guess really I don't need the vertex here, so I won't necessarily have to change it, but you could change your window. You could change that Y max to, say, 120, just, just because I like to see everything. And it gives you an idea of what happens. Remember, anything to the left of this y-axis doesn't matter. It's not happening. It's negative time. Boom. Marcia hits the ball. It goes up into the air, and then it screams down towards the bottom of the cliff. Okay. We can sort of guess that that's going to be 3, but we can use our our calculator to help us. Second trace. I'm finding that 0 again. 0. And then left bound. I'm just going to move that a little bit so we can see the line better. And then right bound. Just get it to the right of that. Anywhere is fine. Notice, see, it's bounded bit this. It's going to find that 0 for us. 3. Okay. X equals 3. So if we go back, we graph the function. And graph the function means on the calculator. You don't need to show me. You can put a diagram of what it looks here, but you can tell me. So find the number of seconds it will take the ball to hit the ground. It'll take 3 seconds. Wow, Schaefer, this is easy. I agree, Sean, and thank you for your question. Example 2 now. Smoke jumpers are firefighters who parachute into in areas near forest fires. Blah, blah, blah. Keep reading. The function y equals negative 16x squared plus 1600 gives us the jumper's height in y in feet after x seconds. So instead of using s and t, we're using y and x. And they jump from 1600 feet, right? That makes sense. That's our starting height. What's our initial velocity is 0 because I'm sort of jumping out of the airplane, which means basically I'm just walking out, not jumping up in the air. I'm just walking out. So the initial velocity is 0. And then how long is the free fall if the parachute opens at 1,000 feet? So a couple ways to do this problem. One, I would automatically do this on the calculator, but I do all these problems on the calculator. But you could say, okay, how long is the free fall if the parachute opens at 1,000 feet? So a free fall means the time prior to the parachute opening. So the parachute opens at 1,000 feet, and so that's y is the height, right? And so that would be negative 16x squared plus 1,600. You could bring that over, set it equal to 0. 16x squared plus 600. Actually, probably should have taken it to the other side. But you could do this equation and find it. You could bring the 600 over, divide by negative 16, and take the square root of both sides. Okay. So I'm just going to do that. So I get x squared is 600 divided by 16. Take the square root of that, and I don't know what you get. But you could do the math. Or, as I would argue, this is what I would do. This is what I would do. It's way more fun, and it's on the calculator. So go back to y equals. Let's put that initial equation in. So that's negative 16x squared plus 1600. Okay. Now, when I hit graph, look what happens. Number one, I'm not going to see it, right? And it will be done in a second. There it is. I don't see anything. I mean, I kind of see something, but I don't really see it. So I got to change that window. So let's think about how I'm going to change that window. The X min doesn't matter because I don't care anything about what's to the left of the Y axis. X max, we could just make it 15, just just so we could see a little bit more. And the X min doesn't matter because once I hit the ground, I hit the ground. Now, remember our starting height was 1600, right? That's our Y. So let's change this from 1200, let's say, to maybe 2000. Now, because I've done this before, I'm going to change my scale to 50. You don't have to do that. It will just, when I graph it, it'll just make these guys look a little better. So here I am. The plane comes up in the air. We're at 1,600 feet. I run out, and that's when I hit the ground. Now, you don't want to do that when you're parachuting unless you've opened your parachute. So the question says, what's the time? How long does it take till I get to 1,000 feet? So I want to know when y is 1,000. So let's go to y equals, and then y2, I'm just going to put in 1,000. Now my calculator is super nice because it has multiple colors. And this is how long it takes to get to 1,000 feet, right? I'm not asking for the x value. I'm saying, what happens when y is 1,000? Well, look where the intersection is. And funny story, when I go to second trace, look at number 5, intersect. Second trace is your friend. Okay, and it says first curve, and you just hit enter. See, first curve, you hit enter. Then it's going to automatically go to the second curve, and you hit enter. And then it says guess, and I don't know what that means, so I hit enter again, and it goes there. Now, you want to make sure this cursor is moved closer to this intersection as opposed to the one intersection to the left. When it came up, our cursor was closer there, so it was easy. Okay, and when you do that, you get an answer of x equals 6.12. So it after 6.12 seconds, your free fall is done and you open the parachute theoretically. And then of course, this wouldn't exist anymore because you're going to fall at a different rate than if your parachute's out than if you weren't, right? The effect of gravity is going to be different for your parachute. But we're not worried about that. We certainly don't want to hit the ground. So 6.12. Okay, so when y is 1,000, so if you go back and look at this equation, y equals 1,000, I put this equation in a separate y equals. That was y2, this was y1, and I just found their intersection. Could I have put this equation in and found the 0? Sure. Sure, I could have put that second one there in and found the 0, but boy, it sure was easy to do that way. So we said, let's find the answer here. There we go. We said t equals 6.12 seconds. And as you can see, x equals 6.12 seconds. Definitely edited. Okay. Whew, we're moving, cooking with gas. Let's go to page 2. Good news, we're not going to do all of them. But I do want to do these last two, or two of the last three. I want to do these last two. I want to save that number 6 to class so that I can see your faces when we do this problem, because I think you'll be astounded, and you'll be filled with joy, really, when we do that problem. That's my guess. Okay. We sort of had a similar problem on the worksheet a couple days ago, and I sort of did it one way, and this is the way you would want to do that. Now, you have a 500-foot roll of fencing in a large yard. Okay. You want to construct a rectangular playground area. What are the dimensions of the largest yard? So two things that work. These are called max, min, problems because I'm either looking for a maximum or a minimum. I want to find the largest yard, or in some problems I might want to find the smallest amount. Okay, but in this case I'm looking for the largest yard. And remember, where does the maximum occur? Well, it's quadratics, so we know the maximum occurs at the vertex. Okay, so I'm probably going to be looking to do something with a vertex. So let's start off by defining the perimeter. And the perimeter is equal to 2L plus 2W. And maybe I should draw this first, right? This is my rectangular yard, right? Length, length, width, width. And I'm just going to I have 500 feet of fencing to put around this yard. Okay, so that's going to be 2L plus 2W equals 500. Okay, that's the perimeter. Maybe I'll make that arrow so the perimeter is that. Okay, now what's the area? The area is given by length times width. The area is length times width. So I'm going to solve this equation for L or W. It doesn't matter. We'll just solve for L. And then we're going to substitute it in here. So over here, I'm going to just say, I'm skipping a couple steps. I'm doing 500 minus 2W and dividing by 2. So I get 250 minus W. Okay, that's the length. And then I'm going to put it in here. So I then have, once I substitute that into the equation, right here, I'm going to put this L. I'm going to say the area is equal to 250 minus W times W. And then you're like, okay, I don't know why that keeps coming up. And I said, I don't know either. So area equals negative W squared plus 250 W. Now you say, Mr. Schaefer, I can't solve that, right? I can't solve for A and I can't solve for W, but I can because I'm not looking for all of the values that fit it. I'm looking for the maximum. Think about this. This is a parabola. This is a parabola. And if I think about what the parabola is looking like, this is the width and this is the area. So it's going to be some upside down parabola, right? And I'm looking for this point right here. I'm looking for the vertex. That'll be the maximum area. It'll tell me what's the width at that maximum area. Now, this one might lend itself to doing without the calculator. You know, I'm loath to say that, but you could. You could do negative B over 2A, negative B, negative 250 over 2A, negative 2 times 1. So you could say the x coordinate or the w coordinate of the vertex is 125. And then, you know, you can go back, you can find the area by substituting in, you can find the area by knowing that all of these are 125 and you have some sort of 125 thing. But let me show you what it looks like on the calculator too. Okay, so this is W, so this equals W. So of course L is going to be 125 and then the area is going to be 125 times 125. But let's look what it looks like on the calculator, because we got this calculator here, we might as well use it. I'm going to clear all this nonsense. Negative, we don't have W, so we're going to use x squared plus 250x. Now when I graph this, I don't see anything. Well, I see that. Okay. But let's think about what our window needs to be. Well, what's the maximum W? What's the maximum, right? The x-axis is the width. So if I go to window, the maximum it could be is 500, right? It could be, well, actually it could be 498. But let's do 200. Just to, I mean, we already know what the answer is, so we'll just be conservative there. And then what's the maximum area? Well, how big can a 500-foot fence be? I don't really know. So I'm going to put in 20,000. See what I get. See what happens. There's my graph. It peaks and then it comes down. And again, I'm not interested in what happens when it hits the ground, right? I'm not interested when the area is 0. I'm interested when I've maximized my area. And where does the maximum occur? At the vertex. So I'm going to do second trace, right? Our old friend maximum, left bound. Yep, that looks like our left bound. Let's move to the right. And again, anything to the right is good. Is good. Enter. It's going to find that maximum. And yeah, we know it's going to be 125. And look at that area, 15,625. I assume it's feet squared. Okay. The x-axis is the width. The y-axis is the area. I'm looking to maximize. So all of problems like this are going to be getting a quadratic and finding the vertex. Okay. So we ended up with, what we say area was 15. Oh goodness, I was just there, 625. Okay. And then what's our dimensions? Well, 125 times 125. Okay. Now, you're saying to yourself, well, of course, it's always a square. It is always a square, but I promise you, in the interest of making it more exciting, we're going to have problems that make it not a square. I'm just letting you know that because I think you want to know that ahead of time. Okay. And then this is the last one we're going to do. Alrighty, let's look at number 5. Now, the nice thing about number 5 is we might not actually have to use the calculator. Whew, those are tough words to say. Okay, but we're going to put this, read the problem. We're going to remember that P is the profit and the price is D. Okay, P and D. And you can see what the function is. And that models the daily profit. So write the function in vertex form. So if I'm going to do this in vertex form, I've got to start by completing the square. So what I'm going to do, I'm going to put that 2,000 over to the other side. Now, sometimes you don't do that when you guys do this, and that's okay. Everybody has their own method for doing this, but I'm just going to put that over there. Okay. And I'm also going to factor out a -1 from this side because it's just going to make our life better. So I have d squared minus 120d. Now, what completes the square here? What do I add to both sides to complete the square? I take half of b, 120, right, in this case, and I square it. So that's 60 squared. So that's plus 3,600. Okay, that completes the square. But remember, I'm multiplying it by -1, so I'm really subtracting 3,600 on this side. So over here, I'm going to subtract 3,600. So I get, from that, I'm going to get P minus 1,600 equals -1 D plus 60 squared. And then if I bring the 1,600 over to the other side, P equals -D plus 60 plus squared, plus 1,600, making my vertex 60 1600. But what does that mean? Well, remember, D is price, right? So the price that leads to the best daily profit is $60, and the amount is $1,600 per day in profit. And that's what that vertex is telling me. Okay. The price that yields the highest profit, $60, and that profit amount is 1600. And I just found that by finding the vertex, because the vertex is where the maximum occurs, or the minimum, but in this case it's upward, excuse me, downward facing, so it's that. Alrighty, folks. Thank you so much. Thank you so much for having a good day. Thank you for doing well on the quiz. I appreciate the time you spent listening to this. There is some bookwork you could do tonight's bookwork, which is mostly review. If you look ahead, we're going to be doing that other bookwork plus some other work in class. So if you got ahead and did the bookwork from 2 nights from now, would be really helpful. Not, you don't have to. And we will spend some time in class next time going over this and then reviewing for the test, because this is the last stuff before the test. Alrighty, folks, get started on some homework. Have a great afternoon, and we'll see you on Tuesday. Thank you.